Hello everyone, welcome to our new video. So in this video, we are forwarding to learn about lower bound and upper bound function implementation using binary search algorithm. So first of all, you get to know about what is lower bound and upper bound function do. So it is like if you are searching for an element into an array, if the searching element is present into an array, then it just give the index of that element. If searching element is not present into an array, so in case of lower bound is just point out the next data element after searching element. So in case of upper bound, it's always point to the next data element. Just like if I say if there is an 1 2 3 4 5 is an array, if you are searching for 3, if you are using lower bound function and you are searching for element 3 in this array, then it's just return 3. And if you are searching in this area, if you are searching for, so I can say if it is a 2 4, so in this area if you are searching for 3 in the array using lower bound function, then it's use the result number 4 because the searching element is not present. So in another case, if it is 2 3 4 5 6, so in this case, if you are using upper bound function for searching element 4, then it's always gives the next data element. So it gives 5 in case of upper bound function. So we are going to know about how to implement it using binary search algorithm. So for implementation, for implementation, we need to know about how it works. So first of all, we are going to create a function which is, we can say we are going to create a lower bound function which is lower bound function. We are pass an array. Okay, we can say the array is why we are pass an array, because we are searching for an element of an array, and in this element we are searching element we can pass as element. So we need to take as input for input of an array. We also take the input of an array and element. So we can say there is an n number of element and there is an int array, and for this we need to take the input of the array. So we can make as vector. So while taking input of the array, okay, so in lower one function, first thing you need to know at the starting where you point out your array. Okay, so so at this point, let's take an example. We are in this array 1 2 3 4 5, and we are searching for two elements. Okay? So at first, where we are pointing at our low and high. So at the starting, we are pointing at our low is equal to 0. This is so far above. We are pointing at our low as 0 and our high as high at last. Okay, high at last, which will be this vector size. So we can say that high as vector dot size, which represents 5. So what we gonna do in this, we need to check. We are searching for two, we are searching for the two elements, so we need to find out the middle element. So first we need to search our searching element are lies into this sorted order or not. So for checking we can say this, if we can say this, it runs only when our high minus low is greater than 1, means their difference is greater than 1, then it only lies. So what it says no is undefined, already defines no. It says, okay, we are coming back for you. So till when high minus low is greater than 1, it means we are searching into this into the area. If it is present, then we need to find the middle element first. Just like take an example, if we are searching for 2, if you are searching for 2, then their middle element becomes 2. So you can say mid becomes high plus low by 2. So we will declare it also in mid becomes high plus low by 2. And after finding the middle element, we need to check it is lies onto a right part or left part. So if it is lies into our right part, so it just says if our middle, if our element lies into right part, just like if you check for element number 4, lower bound function for element number 4. So in this case our middle element will be 3, and this it needs to check our right part. So you just check, while checking you just make their middle element pointing to the their low elements, low pointer becomes the middle plus 1, because it need to search onto a right part, so it need to shift their low pointer on the right side. So we can say the low becomes middle plus 1. And till then, if or we need to find out if our case lies into our right part, lies onto our left part. Just like if you are searching for 2, then how we can search? First we are searching for middle element which is 3. After finding middle element, we just need to iterate onto our left part. So for this we just calculate, we just mark our middle element as high and just calculate the middle element into our left part. So it becomes 2, and when on middle elements becomes 2, then I just return the lower, if lower elements became middle, then I just says returns lower element. So for this we can say in if condition low is middle plus 1, in else condition high will low will shift to high, mid will shift to high. Okay, because we are shifting mid high. So after all this case we need to print out if high becomes mid, then what happens. So for this case we can say if our high became, so at this point if our lower element is pointing to if our lower element is pointing toward low, we can say If all lower element is current element, then we can say just return the lower element. Okay, and else uh, if element is less than or equal to, because we need to return current element also if such element matches, and if not matches we also need to return the next element. So we are doing both. If the current element is less than element, okay, so if or high which is greater than high, then if greater than high or equal to, then it also return element. So we need to also return high. So at this point, after returning low and high, what we're gonna do is simply call the out function. So, for calling out function, it is a lower one function. So we can say this point lower one function, what is parameter v, and element. First we need to take the input of the element for what we are searching for. So after taking input of element, we just call, we can take into a variable, and we just print out that element. Yes, it is here Victor element. Okay. So we need to see the result, like we are searching for lower bound of, in the array there were 5 elements. So it not works. In there were array which have 5 elements, 1, 2, 3, 4, and 5. I want lower one function of 2 element 2, then it says it must lies on index number 1, and here let's know why it returns not okay. Searching element at 1, why it goes on index number 3. So first of all we need to check why it gives 3. So in this time we need to say this, if it is 3 it gives the next element. We need to find out when our element is, when our element becomes less than the low, then we return on low element. We want, because we want the current element or next better element. So if low elements are greater, then I just says just return the low element. Okay, now I need to check it again it is works or not. In an array there are 5 elements, which is 1, 2, 3, 4, 5, and I want to check for element number 2. In this case, why it gives the index number 0? It must be point out at index number 1. We need to check out, we are passing, will be at this point is 0, check input. Okay, return the high index. So at this point, so we did a mistake here. We need to take the input of the element before the vector. So now we wanna check if it is, if it is an error. We have 5 areas, which is 3, 4, 3, 4, 5, 6, and 7, and we need to check for the element number 4. We found out the lower bound of element 4. You can see it's again pointing 0. Why it is pointing 0? So the problem is very easy. We are just inputting an element before searching in array, before reading the array. So we just need to remove it, and just after reading the array. So after reading the array, we need to So our array have 5 elements, which is 2, 3, 5, 6, 7, and I need to check for element number 3. Then you can see it's just represent the index number 1, and it is and the searching element is 3. So if we need to search for upper bound function, then what we can do? So upper bound function only gives the next greater element. So for next greater element, we can say at this point we need to make some changes. So when we need next greater element, strictly next greater element, then we can say when our mid is less than element, just like if we are searching for 4, next greater element of 4, then we first calculate the mid, and after calculating mid we need to search in our next part. So if the searching element is in mid, then we are also searching for next greater element. So we can say if the current element is less than or equal to element, then we need to mark out on low is equal to mid plus 1, because we always need of next greater element. So after this, we can say I begins made, it is okay, and we need to always give next greater element. So we need to discard our middle element. So for discarding it, we can say when our element is less than the low, then only returns low, because we always know we always want the greater element. So we can also remove in high. We always want greater element. So if our element is less than the high, then just return high. So we need to just make little changes, and from lower bound to, we can say this is an upper bound function. So at this point it will be upper bound, and we can also enter changes done to this. It will also become upper bound. So after all of this, we need to see the changes. Okay. Just like if I have an array of 6 elements, which is 2, 4, 6, 8, 9, 9. Okay, and I need to search for element 4. The next data element of element 4. So you can say the next data element will be found at index number 2, which is 6. So that is for today, guys. So we are going to so that's for today, guys. We will meet on our next video. So thanks for today, guys.